Page 19, do first. Good, Jonathan started. Alright, there's a lot of people absent because of the college visits, but I know they're not, but I still need to mark them appropriately on here. So if y'all could just say, here nice and loud if you're here, and if they're not, you don't have to say like, not here, right? Like sometimes that's helpful, but right now if you can just stay silent, then I'll know here or not here, okay? Cool. Just here nice and loud or nothing at all. Israel.
Here.
Felix.
Here.
Edith.
Here.
Eli. Dahlia.
Here.
Stephanie. Diego. Jamie Lynn.
Here.
Sandy. Brandon.
Here.
Brian.
Here.
Juan Carlos.
Here.
Martin.
Here.
Ben. Kennedy.
Here.
Giselle. Caesar. Gustavo.
Here.
Lirio. Tyler. Melanie. Lazaro. Jonathan.
Here.
Messiah.
Here.
Joanna. Kevin. She actually was here.
Kevin was here.
She forgot she had to go. Kevin. Ehong. Christina. Johnny.
Here.
Luis.
Here.
D'Anthea.
Here.
Brian.
Here.
Lovely, thank you. Hmm? What is that?
Oh, my bad. What?
Hey, but I'll still keep going. Hey, camera recording the shows.
Okay, let's see if I can fix it now. All right, let's give you a few more seconds. Brian, have you started your kid? Do you have your notes? Can you go get another section of that folder?
Thank you.
Okay, let's see how we feel about this stuff. It's Friday,
Oh.
so it's a raffle day. So
It is
if you start,
recording.
you get a ticket. Your prize at the end will be you get to just pick something out of my prize box, which means you can pick whatever you want. So there's like little candies in there, and then there's the random stuff like bubbles, and the erasers, and the emojis. You got the emoji eraser that one time?
No, I got a
What'd you get?
sushi eraser.
Sorry, pardon my confusion. I forgot I had those. So those are in there too. So you can pick whatever you'd like, or you could trade the amount of tickets you have. Like let's say you have 3 tickets. You could trade your 3 tickets for double 6 stamps on your participation card.
Ooh, that's
Okay? I'm going to try, since there's less of y'all, like as I go around practicing, stamping how many you have anyways. But if I don't get to it, like you can either redeem them like quickly at the end of class, or the winner, like I said, gets double. Okay? Ooh. But okay, so here we go. Starting off, first ticket. Can someone tell me the end behavior of this graph? Let me find my clicker. Here it is. Found it. Martin. Where's it headed?
Is this odd and even can go like that, right?
Oh, odd and even. So it should be, it can't be odd and even. It should be positive and even. It should be doing what?
Yeah, that.
This one, which is both of them. Cool. Okay, cool. Nice. Infinity, infinity. Way to go. Here you go. All right. For the most number of roots, Brian?
4.
4. For the most number of turning points, Jonathan? 3. For the roots, what do we got? Brandon? Do the roots for me.
0, 2, and 5.
0, 2, and 5. If you didn't get those, you can take a look at my factoring to try to help yourself out. I pulled out a 3x squared, so depending on what your strategy was, you might have gotten the exact same thing for your factors or not, but for your answers, we should all have the same exact thing, okay? That means when we draw our graph, we have a pretty good idea of what's going on, except one other thing to point out. Which of these is special and has a double root, we could call it, or a multiplicity that's even? Giselle.
The x equals 0.
X equals 0.
The power is even, that means it will bounce.
Cool. So right here, this one has a multiplicity of 2, which he says is even. Therefore, this is a bounce, cross, cross. So it didn't ask you to sketch it, but I'm just going to quickly do that so we can reinforce what we did yesterday. 0, 2, 5. Martin says we're up on both sides, so we're going to start from up. At 0, what are we going to do? Bounce. At 2, cross. At 5, cross. And we end up like we want it to be. Okay? Cool? Alright. We feel good about that. If you are still kind of like, hopefully this weekend on your problem set, you can sort some things out. Email me if you have questions. Or come and talk to me Monday if you still are having some issues. Brian, question?
Yeah, you prefer y is done with 0.
Yeah. When we look at our factors, boom, boom, no. Boom, boom, boom. These are our 3 factors, right? Giving us our 3 roots. We look at the little exponent. These technically have a 1 if nothing's there. This has a 2. Whenever that exponent is even, we learned yesterday, it's a even multiplicity. It like bounces or is tangent. Whenever it's odd, it's going to cross through. Cool? Alright, nice. With that being said, think of all the things we've done this week. Polynomials graphing was probably the big thing because we spent 2 lessons on that, and it was very similar to monomials, which have the same end behavior, but they're just like, don't do the crazy things in between, okay? We also solved radicals by isolating the radical and then like squaring or cubing both sides and all of that stuff. All of those things are fair game and things to be kind of studying for next Wednesday for your first quiz. In addition to today, we're going to do regressions on our calculator, and that could be on there too. And next week, we're going to start division of polynomials and some other really important stuff. So I'm going to try to roll in some review and some do first. And in your problem set next week, I'll actually put on some review problems that are like multiple choice and feel almost unit test like. But other than that, we're going to be learning new stuff. So keep refreshing on this old stuff so you don't lose it. And of course your problem set is due on Monday. I already said that. Okay. Today, we are going to take polynomials like these, either a quadratic or a cubic, something that starts with the highest degree of 3, or if it has the highest degree of a 4, it's what we call a quartic. Like think like quattro is 4, right? So a quartic kind of sounds like that. People call those like things quads that have 4 wheels, right? Like anyone ever seen like those things? Okay. So this is called a quartic, cubic, quadratic. We are going to be using equations like this to model real world data, which means our data is not going to be a perfect fit. So what we're going to have to do is what we call a regression. Raise your hand if you've ever heard that word before or think you've done a regression. Yeah, a lot of probably AQR people last year. That probably sounds familiar. I think you did it, you did like a project on it, okay?
Oh, yeah.
If you weren't in AQR, you might still have done things where you like plot a set of data
Like scatter.
and you have to find like the best fit line. That's a linear regression. We are going to be looking more, not lines, but at things that look like this, that your data is doing something and you're like, we'll end up with something curvy like a quadratic or a cubic or a quartic, okay? So our data is not going to be perfectly on the line, but we're going to be finding equations that try to fit our data as much as possible. So you'll notice on your table, you have a extra little stapled sheet of paper that I just brought around. So everyone go ahead and grab one of those. These are the instructions and screenshots for where to go on your calculator to do these regressions, so that if you forget the steps, you can reference it. The notes today are just going to have some problems that we're going to solve. These are going to be like your instructions for where we go, which I'm going to show you, but you might forget in like 2 weeks and need a refresher on, and you should be able to follow these steps, okay? So we're going to start actually not with the problem in your notes. We're just going to start by manipulating this table of values right here that you see at the top of this stapled sheet. So I'm going to pull up my calculator, and you won't see this, but this is what you're looking at, and let's see what we can do. In terms of like quick setting the stage and expectations for this, I've noticed throughout the day, I know I draw all over my jeans too sometimes. Sometimes I put them in my pocket, and then I get like green spots on me. It's the worst. I hate that. In terms of the calculator, there's a lot of y'all. So here's what I'm going to ask for you for what I found to be the most successful on calculator days. So pause. I know some of you are like, I know how to make tables, AQR, woo, and you're like already going. Pause. Pause. Hear me out. Okay. When we're going through calculator stuff, it's like bright, and so you're like distracted by your calculator and you're doing stuff. And I'm saying a few things up here, and it's one, easy to miss, like little things I'm going to say that are going to troubleshoot issues you run into. Second thing that's really tempting is when all of a sudden yours does something funky that's different than what we're doing up here. It's really tempting to, like, with your neighbor really quickly, be like, wait, does yours? And like try to figure it out together, which is awesome because you're talking about math. But what I've noticed becomes difficult because all of a sudden we have like 10 different things going on in the room, and I'm like, then everyone's in different places and I'm trying to solve those different problems. So I am going to try to, before we do something, mention a few things to be careful of to make sure a couple of the issues I've seen before don't happen. So I want you to be like listening carefully for those things. And I'm going to urge you for now, I will tell you when it's okay to like compare with your neighbor and ask them a question. But for now, if you could either raise your hand if yours is doing something different, and I'll tell you like, okay, I'm headed that way. But if you could keep your voices off, then we will be able to get most of the questions answered quicker, I promise. It just works better. Okay, so join me right now on your home screen. I'm going to have us create a new document because we're going to use different pages to like enter our spreadsheet and then go run our regression and do different things, okay? So if you go over here to new document, whoops, not what I wanted. Not my documents, I wanted to go to new document. Good. I'm going to not save my old stuff, I'm just going to start something new. We're going to start a list and spreadsheet, which I know a lot of you guys already know that's where we're headed. Okay. For our list and spreadsheet, I'm going to name the first column X, because that's what it has in the table. The second column Y. And I'm just going to enter in my X's and my Y's. So go ahead and enter really quick for me all of those. And your Y's. You have to type it. Oh, sorry, we're doing the table at the top of your. Oh no! What did I do?
You just started with 0 and 1.
No! Okay, let me try again. Y'all are all gonna win. If it was a race, I would be losing. Say this one. So this is common. This happens. Don't feel bad. We all do it. Okay. Okay, first troubleshooting thing. Are we entered? We're in? Okay, here's the first thing to watch out for. Watch out! Make sure you're still listening. Okay. If right now your cursor is blinking in that 82 and you go on to the next step with me, your calculator doesn't think that you've actually typed anything there yet, even though you can see it. Like if you're still clicking, blinking in that cell, it thinks that 3 does not have a partner yet. You have to literally, like, I know this is really small and most of you already did, but you have to click somewhere else to like have the 82 like pop up as the y that goes with 3. So that's the first thing that I've noticed a lot of people today later get an error, and that might be the reason why. So make sure your cursor is out of the cell. Okay, we are now going to run a regression, and depending on an AQR or on YouTube if you watch videos on regression, or in college if you do regressions, there are a couple different options for like where you do this on your calculator and some things like that. Today I'm going to show you 2 places or 2 ways that you could come up with your equation that you're looking for. One of them I like because it's really easy to like visually see what's going on. Another one I like because it just lists out all the values you need, and it lists your correlation coefficient, which is this thing we're going to talk about that maybe you've heard of, AQR people,
Yeah.
correlation coefficient, okay, and all that. So we're going to go through both of them. So option 1, pick up with me, we're on the front page. We just entered our list. Mid-page it says option 1. If you would like to see your data visually, to draw, sketch, or analyze characteristics of the shape or the end behavior, you can make a statistical graph. So let's see how. We're going to go to Control Doc. Let's start a new page. We are going to add a data and statistics page, number 5, and click on that. And you'll get this crazy looking scatter plot that right now these values don't mean anything until you go till the bottom. You want it to be pulling from your X, and it'll move those, and then you want this to be your Y, and it should form like the third picture at the bottom and look like this pretty curve. We there? Any questions? Okay, voice is back off. So flip to the top of the next page. We have this picture now. If I want an actual equation, I am going to tell you which of these we're looking for, or I'm going to ask you for 2 of them, and you're going to have to compare them and decide which one's better. I think AQR, you probably did a lot of quadratics, but maybe not cubic or quartic so much. So that'll be kind of the difference here, is we're going to be doing a lot of comparing those because we're in like our polynomial unit, okay? So let's take a look and see. I see that this kind of almost looks like an upside down parabola. So I'm thinking, okay, maybe let me try a quadratic, because this is not a problem, we're just like looking at stuff. So let's go and let's run a quadratic regression. And the way we're going to do that on this screen is to go to Menu, Analyze, Regression, and I said I want to do a quadratic. You can do whichever one you want, but I'm going to do a quadratic for right now as our first example. And a little equation will pop up that's a quadratic equation, and it's going to have these different decimals. Now, depending on your settings of your calculator and some things we're going to kind of like troubleshoot today, you might not have like all the decimals I have, or your calculator might be rounding or whatever, but for the most part on this one, I think we should be seeing all of us 3 decimal places, but if not, that's okay. We're going to talk about what to do. Do we have the same numbers, even if yours is kind of rounded different? Do we all have the same? Okay, so that's an example of a quadratic equation regression to try to match our data. Now we want to see whether this is a good fit or not. That's why we use something that we call the correlation coefficient. And for those of you that have taken AQR, it's like this little value that we call R squared by convention. And your calculator can give you that R squared value. So what we're going to talk about now is option 2, because this one showed us the picture and gave us the equation. Option 2 is going to be no picture, but we're going to see our equation and our correlation coefficient. Okay, so let's go ahead and see how we can do that. You can either do this in the table. I think in AQR you guys did this like back in the table, or I'm going to do it in the calculator screen because we're going to be calculating some stuff later anyways. Okay, so I'm going to make a calculator page. We're now in option 2, partway down the second page. I'm going to say Control Doc, and I'm going to add a calculator page. Control Doc, add a calculator page. On there, we can go to Menu, Statistics, and we can run regressions here. by going to stat calculations, and then let's do the same thing. Let's make sure we get the same equation. We're going to do a quadratic, just like we did before, but just here. Yeah, you can do it. You can do it in the table or here. I'm going to do it here because we're going to be calculating some stuff after, and then we'll just already be in a calculator page. So we're going to put x. That's the first one we're referring to, and y. It's going to save your regression to F1, which is helpful to note because later, if I want to use my equation for another point, I can say F1 of, and I can like evaluate it at different points, okay? So I'm in F1. Anyone in a different one? Does their calculator say they're in like F6 or something? Or F2 or F3? We're all in F1? Okay, that's good to know. All right, then we press OK. And we've got those same numbers. Y'all see the same ones as before? Negative 15.381, 30.357, 128.738, except they're just listed out. So we would have to take them and write our equation, negative 15.381 x squared plus 30.357x plus 128.738. So this way, you get your equation, but you have to like write it out. What I like about this way is right here, it gives you, what do we call this thing? The correlation coefficient. Does anyone from AQR remember what this should be close to if it's a good fit? Kennedy? 1. So if this number is close to 1, like this one, 0.999, this means that these points are like really close to being exactly the line that we wrote for that equation. Yep.
Isn't it -1 also at the end?
Yeah, that's actually true. So like depending on whether it's a positive or negative correlation, it's more like the absolute value of this is close to 1. So close to 1 or -1. And as it gets like close to 0, it gets further away. Okay? Good point. Okay. So that is a quadratic. Now a lot of times in pre-cal what we're going to be doing is comparing one regression to the other to see which type of relationship is better. So I will ask a question like, for this set of data, 0, 128, 0.5, 141, what is better, a quadratic, or I could say a cubic? So if you're in this screen, we can just go ahead and now, back to back, do another one. And I can say menu, statistics, stat calculations, and this time I can do a cubic, and tell it x, y, and it's going to be F2 now, because I already have something in F1. And I'll say, okay. And it's going to give me a cubic, so it's going to have 1, 2, 3, 4 numbers, because you need an A, a B, a C, and a D, right? And you will write down, for the sake of time, I'm not going to write it right now, but you'll write down that whole long equation.
Sweet.
Okay? What is its R squared value?
1.
Okay, depending on your calculator right now, what you're looking at, yours might say, anyone say point like 998 or something, or sorry, 9 something, what does it say? 999? Cool. And did yours on that last one say 998?
Oh, yeah.
Yeah, so either way, no matter what your calculator is showing you, it's like the same, we're just rounding different. For both of us, which one is better? A better fit? That one, right? So we're still getting the same answer, so don't freak out if your calculator is showing something slightly different if it's rounding different. But you're still going to say that the cubic was a better fit than the quadratic, the first one we did. Okay? So these are helpful tools to be able to predict things for the future. So let's look at our table. It goes from 0 to 3, right? Let's say I want to know around what the value is going to be for 3.5. What I could do now is I could use either of these, F1 or F2 of 3.5, and see what we get. If they're both a good match, our numbers should be kind of close, but one of them should be better than the other. So I'm going to say F1 of 3.5, and I'm going to say F2 of 3.5, and I'm going to see that those are close, right? They're upper 40s or 50, but obviously different numbers, which is showing us why like these different equations, we want to make sure we have like a good fit, because depending on our equation, we're going to get different predictions for other things, okay? Okay, so that is like the main overview of all of the tools that you have. I, a lot of times, am gonna skip my like graph, because the graph is nice, but I am gonna want like correlation coefficient and some things. So a lot of times I just jump straight to my calculator screen and just run my regression. But I just wanted to show you that if you'd like to use that as well. What I'm gonna ask you to do now is take a look in your notes. There's a free response problem that we're going to spend the last like 20 minutes of class just going through and making sure we can kind of troubleshoot all the calculator stuff. So clear things out, go ahead and start a new document. You're going to enter this new table in there, and you're going to start running the regressions that it asks, starting with problem 1, going all the way through. I think there's 5 or 6 questions about this table, okay?
We don't just move the graph right, it goes through.
So they're more like different options, and like if you had all the time in the world, it'd be nice to do both and like see what it looks like and find your equation and find your correlation coefficient. But a lot of times I just run the regression.
Yeah, make sure you put the name.
Okay, who's got a ticket? I'm gonna come catch you up with stamps. Some of my ticket people from earlier. Okay.
The name and the year and stuff.
Do you have your slave? Can you start putting your table in? Can you start putting your table in? This one? This problem? Cool. Oh, you had one. A ticket? Oh, you picked my darn dog around this morning. No, like we found her. But I let her out in the morning and I play with her. But this morning, like, did I tell you all my cousin's getting married this weekend? Yeah. Anyway, she's getting married, so like, I was actually gonna take the day off, but because we were so tight on lessons with like losing days of party, I was like, so I told them I wouldn't come to this stuff today, but I gotta go like right after school to the stuff going on tonight. So I dropped off my dog to board for the weekend. Yes, I do have dress. But so this morning I was like packing and doing stuff, so I let her out and then just like went back inside, and I forgot we're doing construction on our house, and so the fence is like not quite closed, and she just left. And then I went back outside, she wasn't there, and I was like, my husband had to like drive around the neighborhood. I like was like running around, trying not to like wake up people.
At 6 in the morning.
At 6 in the morning. Like, and then someone called me, and she had gone into their garage and was hanging out, and so then we had to go drive to their house. It was like a mile away. She just like went on into the. Anyways, so we got her, but I was running a little bit behind. She has my name in her. Anyways, keep doing those regressions. Do we have it? You got your data in there? Okay, so now, I like new page, yeah, and then just do a calculator one. We don't even need a picture. Yep, and then go to menu, statistics, stat calculations, and then we want to run a what? That's what we did in our example, but here it says to run a cubic. So go down to cubic. Like go down to cubic, stats. Compute Okay, cool. Now do X and Y. Press enter. Do we got our cubic? Okay, so you graphed it. So again, like you don't have to do the graph. If you want to do the graph, that's great. But then, because you're going to need the correlation coefficient and the cubic, I would make a calculator page and run your regression here. So go to menu, stats, and we want a what? That's what our example was, but what does it say here? Using the regression, find a cubic. So you're going to go down to the cubic. And say X and Y. So y'all notice I've got a couple of y'all I think that are starting to do a quadratic, but that was just the example we did. What does number 1 ask you to do? A cubic. So make sure that you run a cubic, not a quadratic. Cool. And press OK. Okay. And this gives you your list, which means it's this x cubed plus this x squared plus this x plus this. That's your big long equation to write out. And then this is your r squared value.
Yesterday at the USA flag.
Thank you. Oh, that's because you only went to 19A. Right? Did you do these? Okay, go add those in and then run it again. Just add a few more. You're good. No, you're good. Okay, so all you wrote down was the correlation coefficient, which is great. That's part of what you need. But when it says find a cubic model, you now literally have to write down this equation. I know. Yeah, like see how I wrote it for the quadratic? So you, and then for the cubic, I was too lazy and I drew that squiggly line. But like you actually have to write it. Okay. Okay, so you gotta actually write out your equation. And then your correlation.
You use,
which one did you use for this? Yeah, so you did. Okay, I'm seeing good things here. Only thing I'm going to bring you back, because I see a lot of people that have run the cubic and the quartic. I know it's annoying, but when I ask for a cubic model, I actually need, the cubic model is the equation. I know. I need your equation. However, some of y'all are going to be seeing different things based off of your settings. So some people for that A value for your cubic, for example, are seeing 0.000, how many zeros is it? Just tell me how many actually. Not like how many. How many is it?
Like
3. And then 2. Okay, cool. And then it's like 2, 1, 4, 1, 3.
It's a lot of numbers.
2, 4, 2. Okay, 2, 1, 4. But other people have 2.137 e to the negative 4,
Yeah.
which is the same thing because e to the negative 4 means go 1, 2, 3, 4. And hey, look, you've got 0.00021, and if you round this, 4. So those are the same values. So I don't right now want you to think like, oh, my calculator is wrong. It's just your settings. And I'm going to make sure before we take a quiz or a test, when we have like time to set all of our calculators the same way and we're about to actually take an assessment, I'm going to make sure we're on the right settings to make sure we're getting the right number of decimals and all looking at the easiest way to read this. For now, write down what you have, knowing it's the same. If you had 5 here, like that's different, that's wrong. Call me over and let's see what went wrong on your calculator. But if yours is just in 2 different forms, don't worry about it, okay? So this is x cubed. Should have animated this. 1.0 2.28. Mine rounded this 2 decimal places, but I would technically want 3, and so that would be something I would mess with. And then for mine, it said 1.703 times 10 to the 6, which if you actually multiply that out, it's a really big number. Like Melanie says, 1703665.335, which is what I had. 1.703, right? That's what I had, but times 1, 2, 3, 4, 5, 10 to the 6. So see, we have the same thing. Our calculators are just showing it in different ways. Okay? And what was the R squared for one? Someone for a raffle ticket, since I haven't given them any. Jamie?
0.728.
728. Okay, cool. Then we go and we do the quartic, just to flip there really quickly. My quartic, here were the numbers I got. Again, yours might be slightly different. Sorry, it's so blinky. But if you can tell that it's the same number, then that's good enough for now. There we go, found the spot. There we go. Cool? And so I'm not going to write it down. I'm going to be lazy. I'm not going to write down the quartic, but you should have a big, long equation, right? Right? Because you all wrote it down. Cool. So then R squared, your correlation coefficient for B, another person who can tell me what you got for that. Someone that has the correlation coefficient for B, our quartic, Johnny.
Fill this out. Where's gonna get attention?
No, just the R squared value. Hello, 0.729. Okay, so this is the fun part, because writing down the equation is not that fun, but you got to do it if I ask you to. A lot of times though, I'm going to ask just for things about them, and so you won't necessarily have to write it down. For example, in number 3, so I'm going to keep us moving. In number 3, it asks now, which of these models best represents our data? Which of these models best represents our data? Deanthea, which one do you think? The quartic best represents our data. Go ahead, before we share out, and actually let's practice writing like you would on a unit exam. I want you to write what you would write as your explain, and then I want us to share out so I can tell you like, yes, that would be credit, or like, no, you didn't explain enough. So she says it's the quartic. Write down why it would be the quartic. Explain, and then we'll check your explanation. On number 3, write down your explanation, and we'll check. Did you write down your explanation? Ryan, did you write down your explanation? Did you get one for the red folder? That's the one button. Let me see if it's there's not there. Check the red folder on here. Do we have our explanation? For 3? I'll pick someone to read their explanation. And we're going to see if it's good. Juan, you got your explanation? Uh-oh. They brought you paper to distract you. Don't let the office distract you. You got your explanation? You got your explanation, Felix? I'll tell more. Give you 30 more seconds. Which one's the better fit and why? So did you write down our 2 R squared values? So this is the quartic model. Even if you didn't get here, that's our R squared value, 0.729. Which one's better fit?
second one, because that number's closer to where we're trying to get close to. Jonathan, help me out, what's supposed to be close to? 1, which one's closer to 1, 0.7 to 8 or 0.7? So you can write here, the quartic is going to be correlation coefficient.
Alright, if you just came in from the visit, just like stick with me. I already gave you all kind of like the instructions and things that you're going to have to get caught up with. But for now, we're going to keep pushing ahead. I'll come try to check in with y'all, but we'll see what happens. Okay, so for number 3, D'Anthea said that she thought the quartic was a better fit than the cubic. So I want someone now to share what they wrote. This is like pretend unit exam. I'm writing my explanation, and we're going to see, kind of critique and give full credit or not. Messiah, what do you write?
I put quartic shows the best correlation because our correlation coefficient is 461.
Wonderful. Okay. Perfect. What I wrote. Okay, pretend you're reading my answer. You're now the T-shirt, and I say.
Actually, a paper towel.
Okay, paper towel. Okay, this is my unit exam. Take a look. This is my unit exam. Quartic. It's close to 1. Okay, can you tell me what I'm missing? Like, I kind of know what you're talking about, but I kind of know what you're talking about, but you're not going to get full credit because what did you not make very clear? Come on, new people. I'm hearing the same hands.
Hearing hands?
Well, okay. Seeing. Wrong verb. I'm a math teacher. New hands? Anyone? Nen, what do you think? Yeah, that's the sentence. It's close to 1. I got a subject, I got a verb, I got. Okay, but you're on to something. It's a shorter sentence. But why? I don't even mind. It doesn't even have to be a long sentence. Longer is not always better. What's like missing that we need to know? Call. I can't even with you right now. Oh my God. Okay. What's wrong with this sentence? Sit down. She's onto it.
You need to be specific so someone wouldn't know what it means. But by it, you probably mean the correlation.
Perfect. I need to know that we're comparing and like using our academic vocabulary. The correlation coefficient is what we're comparing. That's what's closer to 1 than the other one, right? So you can still say this a lot of different ways in short sentence, long sentence, all that, but I want you to be specific and not just like mention 1. Okay, cool? Okay, perfect. Moving on, we've got still 7 or so minutes. So let's talk about follow-up questions. We've run our regression, and now we can identify a couple other things about our situation. So in part 4, it says, use the best model to predict the average price of electricity in 2015. So it says use the best model, which is using the part we just did. Let's see, Juan, what did we just say was our best model? The cubic or the quartic? The quartic. So we want to use that quartic equation, which most of us have, I believe, in F2, unless your calculator was on a different one, okay? We're going to use F2 to predict our value at 2015, okay? So take your calculator. I don't have mine up here anymore, but I can pull it up. Here it is. Ooh, I didn't put in, this is the old data, my bad, so I can't pull up my calculator. That's not going to help us. Y'all take a look in your calculator and type F2 of 2015 and let me know what you get. Where's my cursor?
I got these cotton.
Melanie's got it. I got it. She's got it. Melanie, what'd you get?
5.994.
Cool. Again, we're on a free response, so let's perfect our answer. We have it, but we are in the context of a situation, so we don't want a number by itself. We don't want a number by itself. We want to talk about 5.994 what? 5.994 what, Jonathan?
Cents
Close. Yes. Cents
per like
per
Years.
kWh, which stands for kilowatt hour, but like you can just write it down like that. Cents per kilowatt hour is how they are measuring this. It's a cost, but it's a cost per kilowatt hour. Yep. Okay, let me come take a look at what's going on. Anyone else that has a different number that needs me to come troubleshoot in their calculator? Okay, cool. I'll come check in with y'all. I'm going to, for right now, skip 5 for the sake of time. In our last few minutes, I want us to take a look at number 6 and refresh our memory on average rate of change. Even you guys that just came in, you can join us for this average rate of change problem on the last page of your notes. Average rate of change is, remember, our change in y over our change in x. So we're actually not even going to use our model here. We're just going to use the table. Let's practice this from Unit 1. And I need a write a sentence statement explaining your answer with the 6 things you need for average rate of change, okay? Try that out. I'm going to go give my last stamps and things. And what else? Oh, check in with the calculator. Thank you. All right, average rate of change, go. Thanks for the reminder. Okay, let me look at yours. I think your quartic numbers. Do you still have yours up, Dahlia? I know, but I want to look at the rest of the equation. Do you still have yours up from before?
Yeah.
Let's compare really quick. Yeah, for some reason, numbers are different for both of them. I think that means something about your table. We would want to go back and check. What did you call it? What is it? And then I'll have to, Leo, I'm gonna have to double check, hold on. Okay, y'all, I wanna close this out so that I can do raffle 2. Deanthea, Leo, I'm gonna have to check in with you about your calculator issues. Really quick, take a look. When you do change in y over change in x, you get 0.163 negative, but you don't write that in your sentence. You would say, from 1982 to 1995, the electricity prices, that's your description, decreased because it was negative at an average rate. You have to say that language because it's not an exact rate, it's an average rate of 0.163, and then your units are not just cents per kilowatt hour. That was your y, and we divided by x's, which are years, so I say kilowatt hour per year. Cents per kilowatt hour per year.
are you rapping?
6524, 6525. Okay, 6519,
Oh, that's one.
6518. Those people come grab it right. You would actually want to
Guys, let's screw it. This ended.
you could actually graph F2, like your model, and
Sí, ya sé que es
line at 7, draw a line at 7,
No, dice recording. Wait,
but it's like
no sé. Dude, I got on the video and I was getting my paper y no sé qué estaba grabando porque estaba cerrado
Did you
con el
stop
video.
it? Did y'all stop in the video?
What is it? This says RCC that is recording?
It seems it is recording.
So